Today we are going to talk about graphing the first and second derivatives. Before we begin, let's discuss why these concepts are so important in calculus. The derivative, defined as simply as possible, is the slope of the tangent at any given point on the original function f. Using this information, we can find the rate of change at any differentiable value of x on the graph f of x. For example, given a function f of x, we can graph the derivative by interpreting the slopes at different various x values on f of x. Let's look at another example, f of x. Let's begin by finding all the points at which the slope is 0. As you can tell by looking at the graph of f of x, the slope at x equals negative 3 and x equals 3 are both 0. That means that on the graph of the derivative, f prime at x, the points 3, 0 and negative 3, 0 both exist. Now let's look at the point 0, 0 on the graph of f of x and observe the slope. As you can see, it is a positive slope and is roughly 2. That means that the point 0, 2 also exists on the graph of f prime of x. Now that we've defined 3 points, it is time to look at the behavior of the slopes beyond x equals negative 3 and x equals 3. As you can see from looking at f of x, the slopes beyond x equals negative 3 and x equals 3 are both becoming increasingly negative. This means that beyond the points x equals 3 and x equals negative 3 and the graph f prime of x, the slopes are also negative, giving us a derivative graph resembling a parabola. Now that we have successfully drawn the graph of the derivative, it is time to draw the graph of the second derivative. To begin, let's look at where the slope of the derivative is equal to 0. After observing, we find that the point 0, 2 on the graph of the derivative has a slope of 0, making the point 0, 0 exist on the graph of the second derivative. Upon further investigation, we can see that the slopes of the values to the left of the y-axis on the derivative graph are positive, making those values above the x-axis on the graph of the second derivative. Likewise, since the slopes of the values to the right of the y-axis on the graph of the derivative are negative, those values are below the x-axis on the graph of the second derivative. This concludes our first video on graphing the first and second derivatives when given f of x.